In this class, I want to explain some more problems. Now, there are three independent events A, B, C. A, B, C, or three independent events such that T of A intersection B complement intersection C complement is equal to 1 by 4 P of A complement intersection B intersection C complement is equal to 1 by 8 and P of A complement intersection B complement intersection C complement is 1 by 4. Find P of A, P of B, P of 4. P of A, P of B, P of C. Now, P of A complement A intersection B complement intersection C complement is 1 by 4. This implies, because these three are independent events, so this implies P of A into P of B complement into P of C complement is equal to 1 by 4. Take it as 1. Now, the next one is P of A complement intersection B intersection C complement is 1 by 8. Implies P of A complement into P of B into P of C complement is 1 by 8. Take it as second equation. Now, third one. P of A complement intersection B complement intersection C complement is 1 by 4 again. That implies P of A complement into P of B complement into P of C complement is 1 by 4. Take it as 3. Now let us take 1 by 3. 1 by 3 implies this by this. P of A into P of B complement into P of C complement by P of A complement into P of B complement into P of C complement is equal to 1 by 4 by 1 by 4. Implies here these two are cancelled. P of A by P of A complement. P of A complement is 1 by 4 by 1 by 4, that is 1. But if you take cross multiplication, P of A is equal to P of A complement. But P of A complement is 1 minus P of A. P of A is equal to 1 minus P of A. You bring P of A to the left side, 2 times P of A is equal to 1. Implies P of A is equal to 1 by 2. Now let us take second by third. 2 by 3 implies this by this you have to take. P of A complement into P of B into P of C complement by third one. P of A complement, P of B complement, P of C complement is equal to 1 by 4 by 1 by 4. No, it is 1 by 4 by 1 by 8 by 1 by 4. Here P of A complement is cancelled, P of C complement. So P of B by P of B complement is 4 by 8. That is 1 by 2. Take cross multiplication. 2 into P of B is equal to 1 into P of B complement. But you can write P of B complement as 1 minus P of B. 2 into P of B complement, 1 minus P of B. Bring this minus P of B to the left side. It will become 3 times P of B is equal to 1. That implies P of B is equal to 1 by 3. Now we have to find out P of C also. You take the first one, or you take if you 1 by 2. Not necessary. From 1. What is P of A? Is 1 by 2 into P of B complement. This implies P of B complement is equal to 1 minus 1 by 3, 2 by 3. So P of B complement is 2 by 3 into P of C complement is equal to 1 by 4. This 2 is cancelled. So P of C complement is equal to 3 by 4. But P of C complement means 1 minus P of C is 3 by 4. This implies P of C is equal to 1 minus 3 by 4 equal to 1 by 4. So those are the values of P of A, P of B and P of C. A die is rolled twice. What is the probability that the number on the second die toss is greater than the number in first toss. When a die is rolled twice, we will get 36 possible outcomes like this. N of S is, you may get 1, 1 or 1, 2, 1, 6, next to 2, 1, etc. up to 6, 6. So altogether 6 into 6, 36 possible outcomes are there in this random experiment. Now here, let us take the event E. Event of the number on second toss greater than number on first toss. That is the required event. So what are the possible outcomes in favor of this? Number on the second toss must be greater than number on the first toss. So with 1, we will get 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. In all these 5 pairs, second number is greater than first number. Now let us take with 2. 2, 1 we cannot take because second number should be greater than first number. 2, 2 also cannot take. So we have to start with 2, 3, 2, 4, 2, 5, 2, 6. Next with 3. You have to eliminate 3, 1, 3, 2, 3, 3. You have to take 3, 4, 3, 5, 3, 6. Next with 4. 4, 1, 4, 2, 4, 3, 4, 4 we should not take. You can take only 4, 5 and 4, 6. Now with 5. Only 5, 6 we can take. And with 6 we cannot take any number, any pair. So how many pairs are there with that condition? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pairs are there with that condition. So the probability for E, P of E is equal to N of E by N of S. That is equal to 15 by 36. We can cancel 3. That is 5 by 12. Next I will explain one more sum. A pair of dice is rolled. What is the probability that neither die shows 2 given that the sum of the two numbers is 7. It is a problem on conditional probability. Here it is given that the sum of the two numbers on the two dice is 7. Then in that case, what is the probability that no die will show 2, neither die? What is the probability? First of all, let us take the E. First, if you roll 2 dice, what is the total number of sample points? That is N of S. N of S is equal to N of 1, 1, 1, 2, etc. up to 6, 6. That is 36. 36 possible outcomes are there. Let us take E is equal to event of not getting 2 on either day. We should not get 2 on either day. So how many possible outcomes are possible with that condition? N of E is equal to N of 1, 1. We won't get 1, 2, 1, 3 up to 1, 6. 2, 1, 2, 2, 2, 3 we won't get. Again with 3. Like that up to 6, 6. How many possibilities are there? 2 should not be there on either side. So with 2 you will get 12 pairs. With 2 you will get 12 pairs. So what are the remaining pairs? With 2, what are the pairs? 1, 2, 2, 2, 2, 2, 3, 2, 2, 3, 4, 2, 2, 4, 5, 2, 2, 5, 6, 2, 2, 6, 4, 5, 6, 7, 8, 9, 10. One, two, 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 3, 2, 4, 2, 5, 2, 6, 2, and 2, 1, 5, 6, 7, 8, 9, 10, 11 pairs are there with 2. That means you will get 36 minus 11, that is 25 only. Without 2, you will get 25 pairs. And here we shall take this sum of the numbers is 7 as A. A is equal to event of getting total 7. That implies N of A You take all the pairs whose total is 7. Let us take with 1. 1, 6, total is 7. 2, 5, total is 7. And 3, 4, total is 7. 4, 3, total is 7. 5, 2, total is 7. 6, 1, total is 7. How many are there? 1, 2, 3, 4, 5, 6 are there. So what is P of and what is N of A intersection E intersection A? E intersection A. 1, 6 is there. 2, 5 you cannot take. It is not there in E. 3, 4 you can take. 4, 3 also you can take. 5, 2 you cannot take because 2 is there. 6, 1 you can take. So these are the common sample points for E and E. How many are there? 4. Now let us find out the probabilities. P of A is equal to N of A by N of S. N of A is equal to 6 by 36, that is 1 by 6. P of E, N of E by N of S. N of E is 25 by 36. And P of A intersection E, N of A intersection E by N of S. That is 4 by 36. Now, here sum is given as 7. That should be A. That is A. Now we want to find out probability for A is equal to P of A is equal to formula. P of E by A. Not this one. P of E by A is required. That is P of E intersection A by P of A. That is equal to 4 by 36 by P of A is 1 by 6. Equal to 4 by 36 into 6 by 1. That is 4 by 6 equal to 2 by 3. That is the probability for not getting 2 on either die when the total is 7. Okay. Now I will explain one more sum. A and B are independent events. Show that A complement and B complement are also independent. Now here A and B are independent. That means A and B are independent implies P of A intersection B is equal to P of A into P of B. Now we have to show that A complement and B complement are also independent events. Now, what is P of A complement intersection B complement? That is now whenever this intersection is there, that is P of A union B whole complement. For intersection we have to use union. For union, you have to use intersection for whole complement. This is 1 minus P of A union B. Now it is equal to 1 minus P of A plus P of B minus P of A intersection B. But A and B are independent events. So this is 1 minus P of A minus P of B plus minus into minus plus, but this is P of A into P of B into P of B. Now from the first two you can take 1 common. 1 into 1 minus P of A. From the last two you take minus PB common. P of B. So it is 1 minus P of A. Now take 1 minus P of A common. 1 minus P of A into 1 minus P of B. But 1 minus P of A is P of A complement. This is P of B complement. Now P of A complement intersection B complement is P of A complement into P of B complement. That implies A complement and B complement are independent. Okay. Now it's shown that these two events are independent. Now one more sum. P of A is equal to 0.6. P of B is 0.7. A and B are independent. Find 1. P of A intersection B. 2. P of A union B. 3. P of B oblique A. 4. P of A complement intersection B complement. Now first, here A and B are independent events. Independent events. 1. P of A intersection B is equal to P of A into P of B because they are independent. That is equal to 0.6 into 0.7, 0.42. Next one is P of A union B. Formula for P of A union B is P of A plus P of B minus P of A intersection B. P of A is given as 0.6. This is 0.7 minus P of A intersection is calculated as 0.42. So 0.6 plus 0.7 is 1.3. We can write 1.30 minus 0.42. Subtract 8, 0.88. And next, third one. P of B by A. P of B oblique A. Formula is P of A intersection B by P of A. equal to P of A intersection B is calculated already. It's 0.42. By P of A is 0.6. You can put 60 also. Multiply numerator and denominator with 100, you will get 42 by 60. Cancel 6. That is 7 by 10. You can write it as 0.7. Now the fourth one. P of A complement intersection B complement. That is P of A complement into P of B complement. Because A and B are independent events, A complement and B complement are also independent. That's why it is 1 minus P of A. This is 1 minus P of B equal to 1 minus P of A is 0.6. 1 minus P of B is 0.7. So equal to 0.4 into 0.3. That is 0.12. So that is the probability for A complement intersection B complement.